To calculate an error interval, we are first looking at our lower and upper bounds, the point at which we round to. Our first question says we are rounding to two significant figures. So in the case of 340, we're rounding to the nearest 10. I'm going to demonstrate the intervals by writing these on the number line, starting right in the middle with the number that we've rounded to, 340. If we're rounding to the nearest 10, the 10 below would be 330. I could fill in 320, 350 and 360 in the same way. So our statue has been rounded to here. Now what we're looking for is the point of crossover between rounding down to 330 or rounding up to 340, and that is always this halfway point. So on this particular number line, the halfway point between those two figures is going to be 335. Approaching this number anywhere here, 334 for example, will be rounded down here. This is the first point at which our weight would be rounded up to here. This represents S. Going for our upper bound, the point at which it switches over to be rounded to the next 10 is right here, 345. So there we've identified the range of rounding. That is our error interval. We just have to work out how to write it. The rules of rounding say that when the figure reaches the 5, we round up. So our statue is going to weigh greater than or equal to 335. Because at the point of 345 we round up, our statue has got to weigh anywhere less than 345. So this notation is the answer to our question. Our statue is greater than or equal to 335, but less than 345. I'm going to do a similar thing. This time is for the rounding to 2 decimal places. So I'm going to put my rounded number in the middle of my number line, 112.63 to 2 decimal places. I'm going to fill the rest of my number line with the numbers to 2 decimal places below and above. I could actually populate the rest of my number line so that it makes sense. But this is my rounding. So I need to find the crossover point between rounding down to 112.62 or rounding up to 112.63, and as always it's this halfway point. Halfway between these two figures is 112.625. Written very tiny, I hope you can see that. And the point of crossover above our target amount is 112.635. So the error interval for the length of my road R is greater than or equal to 112.625 but less than 112.635. 0.635. I'm going to do this example for the next three amounts so that you can see how we change the number line according to what we're rounding to. The next example is for the nearest whole number. A quantity of cola in a can rounded to the nearest whole number is 330. 330 millilitres to the nearest whole number. So here is 329, 328. I'm counting in single units. 331, 332. I've rounded my number to here, so I'm looking for this crossover point here, 329.5. The upper bound here, 330.5. So C is greater than or equal to 329.5, but less than 330.5. My last example is counting in tens. The width of my page rounded to the nearest 10 millimetres is 210 millimetres. So 210 millimetres is in the middle. Counting in tens, this would be 200 millimetres and this 190. Going up above, this would be 220 and 230. If I'm rounding here, my crossover point is here. Halfway between 200 and 210 lies 205. P is greater than or equal to 205. Going up the number line, my crossover point is 215. So P is less than 215.